The Heerema Thialf is renowned as the largest crane vessel in the world, both in terms of its size and its extraordinary lifting capacity. It is a monumental engineering feat, designed specifically for offshore construction, heavy lifting and installation projects, particularly in harsh and challenging marine environments. The Thialf is not just a marvel of size, but also a technological powerhouse that supports the oil, gas, and renewable energy industries, playing an essential role in offshore operations where precision, strength, and reliability are critical. Constructed by the renowned Dutch company Heerema Marine Contractors, the Thialf is a semi-submersible crane vessel that has been operating since its delivery in 2009. It is a highly specialized vessel, equipped with two of the most powerful cranes ever built for marine use. These cranes are capable of lifting massive weights, ranging from offshore oil platforms to entire subsea structures, positioning them in the most challenging offshore environments. The Thialf was engineered to support some of the most demanding lifting operations, including the assembly of offshore wind farms, the construction of large oil platforms, and the removal and replacement of subsea components. The sheer scale of the Thialf itself is impressive. The vessel is over 200 meters in length, with a beam of more than 90 meters, making it one of the largest vessels of its kind on the seas. It is powered by 4 powerful engines and is equipped with dynamic positioning systems that allow it to remain stationary even in the most challenging sea conditions, without the need for anchors. This level of stability is essential when conducting high-precision operations that require careful handling of extremely heavy and valuable loads. Cranes and lifting capacity. The Thialf is equipped with 2 enormous cranes, the portside crane and the starboard crane. Each of these cranes is a technological marvel, designed to carry out the most complex and heavy lifting operations in offshore construction. The starboard crane in particular is a key feature of the Thialf and stands out for its enormous lifting capacity and operational versatility. The Thialf's cranes have a combined lifting capacity of 14,200 metric tons when working in tandem, making them capable of lifting some of the heaviest objects ever to be moved offshore. The starboard crane alone is capable of lifting up to 1,400 metric tons in single lift mode, a remarkable feat of engineering. This immense power allows the crane to move large, complex structures such as subsea platforms, heavy pipes, and entire sections of offshore wind farms, making it a crucial piece of equipment for some of the most challenging offshore projects. Both cranes are equipped with lattice booms, which are made from multiple intersecting beams and are designed to support immense weights while offering flexibility for long reaches and heavy-duty tasks. The lattice design ensures maximum strength and durability, making it possible for the Thialf to operate in the most extreme offshore conditions, such as in deep water or areas with high wave and wind conditions. The starboard crane in action. One of the most remarkable aspects of the Thialf is the performance of its starboard crane, which can be observed in action during a variety of high-profile offshore lifting projects. The starboard crane is often the focus of attention because of its size, power, and ability to move massive loads with high precision. Its lifting capacity is enough to lift entire offshore platforms, subsea modules, and other extremely heavy structures. What sets the Thialf apart from other crane vessels is not just its lifting power, but the efficiency and speed with which it performs operations. When the starboard crane is in operation, it can be seen swinging into action with remarkable agility. One of the key features of this crane is its fast turning capability, which allows it to rotate rapidly and reposition itself with incredible speed. This quick turning capability is essential in marine operations where precise placement of heavy structures is required. For example, when positioning large oil rigs or subsea modules, the starboard crane can swiftly adjust its angle, quickly realigning the load for placement. This ensures that the crane can carry out operations with minimal delay, which is vital in offshore construction, where time is often of the essence, and the weather conditions can change rapidly. The fast turning of the starboard crane is facilitated by advanced hydraulic systems and winches, which allow the crane to rotate smoothly and with high precision. This is especially important when working in tight spaces, such as when lifting structures into small subsea locations or installing parts of an offshore wind farm where maneuverability is crucial. With its precision controls, the Thialf's operators are able to turn the crane's boom with incredible accuracy, ensuring that large, complex structures are moved safely and efficiently. The dynamic positioning system on the Thialf also plays a critical role in the performance of the starboard crane. This system uses a network of thrusters and propellers to keep the vessel in the correct position, even in rough seas. This stability allows the crane to maintain a steady platform for lifting and moving heavy loads, reducing the risk of accidents or complications during operations. This is crucial for offshore projects that take place in harsh and ever-changing marine conditions, where safety and precision are paramount. Moving and lifting massive loads. The Thialf is designed to lift and move some of the heaviest objects ever encountered in offshore construction. One of the most common tasks the vessel performs is placing large sections of offshore platforms or wind farm foundations into position on the seabed. The starboard crane's impressive lifting power enables it to lift structures weighing hundreds of metric tons and move them with remarkable precision. For example, during offshore oil platform installations, the starboard crane might lift an entire section of a platform weighing more than 1,000 metric tons and transport it to its designated location on the seabed. The crane then carefully lowers the platform into place, adjusting the angle of the load to ensure a perfect fit. This level of precision is possible because of the advanced technology on board the Thialf, including its highly responsive crane controls and dynamic positioning systems, which work in tandem to ensure the safety and accuracy of every lift. The Thialf is also capable of performing tandem lifts, where both the portside and starboard cranes work together to lift a single massive load. In this configuration, the combined lifting capacity can exceed 14,000 metric tons, allowing the vessel to lift entire subsea structures or large sections of offshore platforms in one go. These tandem lifts are essential for larger offshore projects, where the lifting and placement of large structures must be done with extreme precision and at great depths. Stability and maneuverability. One of the most challenging aspects of offshore lifting is the need for stability during operations. The Thialf, despite its enormous size and the sheer weight of the loads it lifts, is remarkably stable. This stability is achieved through a combination of design features, including its semi-submersible hull, which provides a low center of gravity and excellent stability, even in rough seas. The Mammoet SK6000 crane is currently undergoing its final testing phase, and everything seems to be in perfect working order as it prepares to enter active service. This state-of-the-art crane, known for its impressive lifting capacity, has been thoroughly evaluated for performance, stability, and safety, ensuring that it can handle the most demanding heavy-duty tasks. As the testing progresses, the crane's powerful engines and precise movements are drawing the attention of a captivated audience. The SK6000 is designed to lift massive loads, ranging from heavy equipment to large structural components, which makes it essential for industries like construction, oil and gas, and offshore operations. Watching the machine in action is a truly awe-inspiring sight. The crane's advanced hydraulic system and lifting mechanism allow it to perform complex operations with unparalleled precision, even under extreme conditions. The audience watches intently as the crane effortlessly lifts and moves heavy equipment, showcasing its immense strength and capability. The process of loading and unloading such substantial objects seems almost effortless thanks to the cutting-edge technology and robust engineering behind the SK6000. With its flawless performance during testing, it is clear that the crane is ready to take on the most challenging lifting projects, providing both efficiency and reliability for future operations. The spectacle of such heavy-duty lifting is not only a demonstration of engineering marvels, but also a reminder of how far technology has come in making large-scale construction projects safer and more efficient. The Mammoet SK6000 is truly a testament to the power of innovation and its ability to meet the demands of modern industry. The Terex CC6800 is an engineering marvel, a giant lattice boom crawler crane designed to tackle the heaviest and most complex lifting operations. With an impressive lifting capacity of 1,250 metric tons, the CC6800 stands as one of the most powerful cranes in its class, capable of lifting massive loads with precision and ease. This crane, equipped with a robust lattice boom, is particularly designed for heavy-duty tasks such as lifting and moving large structural components, especially in challenging construction environments. It is no wonder that the CC6800 is highly regarded in industries like heavy construction, oil and gas, and infrastructure development. Recently, the Terex CC6800 was put to the test in a remarkable feat of strength and precision, lifting and moving an enormous concrete bridge section weighing 140 metric tons. This section, which was integral to the construction of a major transportation project, required the use of specialized equipment to ensure both its safe lifting and accurate placement. The CC6800's sheer lifting capacity, combined with its cutting-edge hydraulic systems, made it the ideal choice for the job. The process of lifting such a massive load with the CC6800 is nothing short of spectacular. As the crane slowly and steadily began its lift, onlookers couldn't help but marvel at the sheer power of the machine. The lattice boom, which extends to impressive lengths, is designed to provide both strength and flexibility, allowing the crane to achieve optimal load distribution. This ensures that the heavy concrete section is lifted with minimal sway, ensuring that it remains stable throughout the entire maneuver. The crane's precision controls allow the operators to manage the load with millimeter-perfect accuracy, guaranteeing the safety of the entire operation. Moving the 140 metric ton bridge section across the construction site was a delicate operation. The CC6800 carefully shifted the massive load, ensuring that it was perfectly balanced throughout the process. The crane's crawler tracks, built for stability and maneuverability on soft or uneven terrain, allowed it to smoothly move the heavy concrete structure from one location to another. As the crane carefully transported the bridge section, the precision of its movements was a testament to the level of engineering that went into creating this powerhouse of a machine. Once the bridge section reached its designated spot, the crane's operators carefully lowered it into position with controlled finesse. The process of lowering such a massive object with extreme precision requires careful attention to detail, and the Terex CC6800's advanced hydraulic systems ensured the load was placed accurately without any issues. The entire operation, from lifting to moving and finally placing the bridge section, took place with such precision that it was almost as though the crane had effortlessly lifted the weight of the entire structure. In conclusion, the Terex CC6800's ability to lift and move a 140 metric ton concrete bridge section demonstrates the immense capability of this crane. It is a perfect example of how modern engineering has achieved new heights in heavy lifting, with powerful machines like the CC6800 playing a crucial role in the success of large-scale infrastructure projects. The incredible lifting power, precise controls, and stability of the crane are key factors that make it an invaluable tool in the world of construction. The Saipem 7000 is a true giant in the world of offshore construction and heavy lifting. Known as one of the most powerful and capable marine crane vessels ever built, the Saipem 7000 is designed to perform the most demanding lifting operations in the offshore oil, gas, and energy sectors. With its advanced technology and immense size, it plays a pivotal role in large-scale offshore projects, particularly for the installation of oil platforms, subsea infrastructure, and renewable energy installations, such as offshore wind farms. Design and features of the Saipem 7000. The Saipem 7000 is a semi-submersible crane vessel, SSCV, that boasts remarkable dimensions, With a length of over 200 meters and a width of about 88 meters, its semi-submersible design allows it to maintain stability even in the most challenging sea conditions, which is critical for offshore lifting and installation operations. Unlike traditional crane vessels, the semi-submersible design of the Saipem 7000 provides exceptional stability, even in rough seas, allowing it to carry out heavy lifting operations with minimal sway or movement. One of the standout features of the Saipem 7000 is its two massive heavy lift cranes. These cranes are capable of lifting extremely large and heavy loads, with the main crane having a lifting capacity of up to 3,000 metric tons, and the auxiliary crane capable of lifting up to 1,000 metric tons. When used together in tandem mode, the two cranes can lift even heavier loads, making the Saipem 7000 ideal for installing some of the largest and most complex structures in the offshore industry. The Saipem 7000's cranes are equipped with hydraulic systems that allow for smooth, efficient lifting operations. The cranes are designed to perform both single lifts and tandem lifts, which allows for greater flexibility depending on the size and weight of the load, whether lifting large offshore oil platforms, subsea structures, or massive wind turbine foundations. The Saipem 7000's cranes are built to handle the toughest offshore construction challenges. Lifting and installation capabilities. The Saipem 7000 is primarily used for heavy lifting and installation of offshore structures. Its cranes are designed to lift extremely large loads such as oil platforms, drilling rigs, and floating production storage and offloading (FPSO) units. Offshore platforms can weigh hundreds or even thousands of metric tons, and the Saipem 7000 is equipped to handle these massive loads with precision. The main crane, with its 3,000 metric tons lifting capacity, is particularly adept at lifting entire sections of offshore oil platforms, which are then transported and installed on the seabed. In addition to its impressive lifting power, the Saipem 7000's cranes are equipped with advanced dynamic positioning systems. This system allows the vessel to maintain its position in the water, even in rough seas, ensuring the cranes can perform lifts with extreme accuracy. This dynamic positioning is essential for offshore lifting operations where the vessel must remain stationary and stable while handling massive loads. The Saipem 7000 is capable of performing high-precision operations, making it a preferred choice for placing subsea equipment, installing platform sections, or carrying out deep-water lifts. The Saipem 7000 is also used for subsea pipeline installation and the construction of offshore wind farms. For example, in offshore wind projects, the vessel's cranes are used to lift and place large wind turbine foundations into position on the seabed. These foundations can weigh several hundred tons, and the Saipem 7000's cranes are capable of moving them with great precision and efficiency. As the demand for renewable energy grows, the Saipem 7000 has become an essential tool for offshore wind farm construction, where its lifting capabilities are vital for installing turbines in deep-water locations. Tandem lifting and precision operations. One of the unique capabilities of the Saipem 7000 is its ability to perform tandem lifting. Tandem lifting is a technique where both the main and auxiliary cranes work together to lift a single load. This increases the overall lifting capacity of the vessel, allowing it to handle even heavier loads. Tandem lifts are particularly useful when the structure being lifted is too large or too awkwardly shaped for a single crane to handle on its own. By using both cranes in tandem, the Saipem 7000 can lift entire subsea modules, large platform sections, or other heavy structures that require extra lifting capacity. The ability to perform tandem lifts also enables the vessel to handle projects that require the highest levels of precision. Lifting massive offshore structures requires careful coordination between the two cranes, and the Saipem 7000's cranes are equipped with sophisticated monitoring systems to ensure that both cranes work together seamlessly. These systems provide real-time data on load distribution, crane movements, and environmental conditions, allowing the operators to make adjustments quickly and efficiently to ensure the success of the lift. Tandem lifting is also beneficial in challenging environments, such as deepwater locations where the seabed is at great depths. In such conditions, the Saipem 7000's cranes can work together to lift heavy structures and position them accurately on the seabed, even in the most challenging offshore conditions. This makes the Saipem 7000 ideal for use in projects that involve deepwater installation or complex offshore construction.